In this discussion, we'll be working with domains of rational expressions. So I will be working with two rational expressions, 25x squared minus 4 over 67 and 5 minus 9w over 9w squared minus 4. So let's get just a few terms out of the way first. Fractions with variables in them are called rational expressions. A variable, it's just simply a number whose value we do not know yet. The domain of any algebraic expression in one variable is the set of all real numbers that can be used in place of the variable. It is also important for you to remember that each polynomial must be fully factored and that you can only cancel factors. You cannot cancel terms. Okay, on your screen are the two rational expressions. Okay, so let's work with the first one, 25x squared minus 4 over 67. This binomial can be factored using the difference of squares formula because both terms are perfect squares. The difference of squares formula is a squared minus b squared, which is factored into a minus b multiplied by a plus b. So let's go ahead and factor that. Okay, and we'll put that over 67. 67 is a prime number. All right, so the domain of the rational expression is all real numbers except where the expression is undefined. In this case, there is no real number that makes the expression undefined, so the domain is all real numbers. All right, so since it's impossible for 67 to equal 0, there are no excluded values for the domain. So we can say that the domain is the set of all real numbers. Written in set notation, this would look like this. Or even more simply, you could just say domain equals all real numbers. Okay, in our second rational expression, we need to reorder the polynomial 5 minus 9w alphabetically from left to right, starting with the highest order term. Okay, so it would look like this. Minus 9w plus 5 over 9w squared minus 4. All right, so next week we're going to factor out the greatest common factor of minus 1 from the expression minus 9w. Okay, next we're going to factor out the greatest common factor of minus 1 from the expression 5. And now we'll factor out the greatest common factor of minus 1 from minus 9w plus 5. So now let's move the minus 1 to the front of the fraction. All right, the binomial can be factored using the difference of squares because both terms are perfect squares. All right, the difference of squares formula is a squared minus b squared, which factors to a minus b times a plus b. So the domain of an expression is all real numbers except for regions where the expression is undefined. So let's go ahead and set the first factor equal to 0. And then solve it. At this point, our goal is to isolate the w, get it all by itself. And as you can see, 2 is being subtracted from 3w. So let's go ahead and add 2 to both sides. Okay, remember we have to keep our equation in balance. All right, so now the w is still not by itself. It's being multiplied by 3. So we're going to undo that multiplication by using division. So we're going to undo that multiplication by using division. The factors of 3 cancel out, and we're left with 2/3. All right, now let's set our second factor equal to 0 and then solve it. All right, well, 2 is being added, so to undo addition, we use subtraction. So we're going to subtract 2 from both sides. Okay, the w is still not by itself. It's being multiplied by 3. So to undo multiplication, we use division. Cancel out the common factors, and we're left with w equals minus 2/3. Okay, so this final solution is all the values that make 3w minus 2 times 3w plus 2 equal to 0 true. All right, so that's w equals 2/3 and minus 2/3. All right, so the domain of the rational expression is all real numbers except where the expression is undefined, right? So that's w cannot equal 2/3 and minus 2/3. All right. So the domain for the second expression is the set of all reals excluding plus and minus 2/3. So in set notation, this can be written as d equals w set of all reals, w not equal to plus or minus 2/3. Now both my expressions do not have excluded values. In one expression, I have no excluded values because there is no variable in the denominator, and a non-zero number will never just become 0. In the other expression, our second expression, there are 2 excluded numbers because both, if inserted in place of that variable, would cause that denominator to become 0, which then means the whole expression would become undefined. And that concludes this video.